Hi everybody, Mrs. Pesic here. We are continuing our look at section 4.3 on using right triangle trig, and we did talk in class about using SOHCAHTOA. All right, SOHCAHTOA, just change my line there a little bit. So SOHCAHTOA, sine is the opposite over hypotenuse, cosine is the adjacent over hypotenuse, and tangent is the opposite over the adjacent. So if we're trying to find the 6 trig functions of this angle theta here, then we are going to need to use SOHCAHTOA. So the sine is the opposite over hypotenuse, all right? And so if that's what we're using, the opposite side would be this side here. That's the opposite side. The hypotenuse would be 13, and we do need to find this side. I'll call it x. That's going to be our adjacent leg. And so in this case, if I'm trying to find that side, I can do x squared plus 12 squared equals 13 squared. And then working this out here, we would get x squared plus 144 equals 169. Subtract 144 from both sides, we get x squared equals 25. And take the square root, and we get x equals 5. Right, and 5, 12, 13 is one of our special Pythagorean triples that maybe you can, work on remembering. So in this case, if I want sine, that's the opposite over the hypotenuse. And so that's going to be 12 over 13. The cosine is slide this over. Cosine is the adjacent over the hypotenuse. And so that is going to be, let's see, changing my thickness of my lines. So that's going to be the adjacent over the hypotenuse. And so that is going to be 5 over 13. The tangent is going to be opposite over adjacent. And so that is going to be 12 over 5. And cosecant is just the reciprocal of sine. So that's going to be 13 over 12. Secant is the reciprocal of cosine. So that's going to be 13 over 5, and cotangent is the reciprocal of tangent, so that's going to be 5 over 12. At least that's supposed to be a 5/12. Hopefully you can read that. All right, get rid of that one. All right, so that brings us to this example, and these are all on your notes gift that I gave you in class. So without a calculator, we're trying to find the following. We're going to try and find sine of 45, tangent of 45, cosine of 45, and so on. So let's work on that. First, I'm going to slide this down a little bit, slide this up, and see what we're trying to find. So I have our sketch of 45-45 right triangle to help us, and one of our 30-60-90 triangle. And again, we are going to use SOHCAHTOA, so let me remind us of that. So I am using SOHCAHTOA for both of these triangles to answer all of these questions. So if I want sine of 45, let me just take this 45-degree angle here. Sine is opposite over hypotenuse, so the opposite side would be 1, and the hypotenuse would be square root of 2. So I need 1 over square root of 2. Now I'm not going to leave a radical in the denominator, so I'm going to multiply by square root of 2 over square root of 2, and I'm going to get square root of 2 over 2. Likewise, if I was going to find the cosine of 45, I'm skipping down to this one now. Cosine of 45 would be, let me erase what I have here. So if I say I want the cosine of 45, that's going to be, again, if I take this 45-degree angle, I want the adjacent over the hypotenuse. That's still going to be 1 over square root of 2, and it's still going to give me this answer, just like we got for sine. Now, what about the tangent of 45? Well, the tangent is the opposite over adjacent. So if I take this angle and I want opposite side over the adjacent, that's just 1 over 1, which is going to give me 1. All right, let's focus now on the 30-60-90 triangle over here. So if I want to find the sine of 30 degrees, I need, again, we're using SOHCAHTOA, so I need opposite side over hypotenuse. So this is the opposite, this is the hypotenuse, so I get 1 over 2. All right, so the sine of 30 degrees is 1/2. Cosine of 30, here's my 30, and I want to get the cosine, that's going to be the adjacent side over the hypotenuse. So that's going to be square root of 3 over 2. That's supposed to be a 2 there. And then the tangent of 30 is opposite over adjacent. So that would be 1 over square root of 3. So if I write that here, 1 over square root of 3, and I'm going to simplify that by multiplying by square root of 3 over square root of 3. And so I end up getting square root of 3 over 3. That's the tangent of 30 degrees. Now, if I want to find the sine, cosine, and tangent of 60 degrees, I am going to need to erase a little bit here. I'm going to get rid of this here, and we're going to be focusing instead on the 60-degree angle. So in this case, slide this down a little, slide this down a little bit. All right, so in this case, we are focusing on the 60-degree angle. And if I want the sine, that means I want the opposite, which would be the square root of 3 over 2, over the hypotenuse. This is opposite, this is hypotenuse. And so I need the square root of 3 over 2. If I want the cosine, then I want the adjacent over the hypotenuse. So this is going to be my adjacent side here. And so if I want adjacent over hypotenuse, that's going to be 1 over 2. And then I get the tangent of 60 by doing opposite over adjacent. So I should really be sliding this along to show what we're doing. So I did cosine was adjacent over hypotenuse. Now I'm doing tangent, which is opposite over adjacent. So the opposite side is square root of 3, and the adjacent is 1, so I get square root of 3 over 1, which is just square root of 3. Now I do want you to notice something about what we have here. I would say notice, try this again, I would say notice that the sine of 30 degrees was 1/2, and that was equal to the cosine of 60 degrees. That was equal to 1/2. And likewise, the cosine of 30 degrees was square root of 3 over 2, and that's the same as the sine of 60 degrees. That was equal to square root of 3 over 2. So with that in mind, let's continue our conversation. Note that sine of 30 equals cosine of 60, and that will always happen when you take the co-functions of complementary angles. So for example, the sine of 70 degrees, sine of 70 degrees is going to be equal to, I need the co-function of sine, which is cosine. Oh, that looks terrible. Try this again. Equals the cosine of, and I need the complement of 70 degrees, which is 20 degrees. How about the cosecant of 40, for example? Well, the co-function of cosecant would just be secant. You can read my writing there. So this, I want secant of, and now instead of 40, I need the complement of 40, which would be 50 degrees. So the cosecant of 40 degrees is equal to the secant of 50 degrees. All right, so in general, then, we can fill these out. So, for example, we can say that the sine of 90 minus theta is going to be equal to, I need the co-function of sine, which is cosine, and I need the complement of 90 minus theta, which is just theta. All right, cosine of 90 minus theta is going to be the co-function of cosine is sine. Just add a co or take the co off. So sine, and the complement of 90 minus theta is theta. And the tangent of 90 minus theta, put a co in front of the tangent and you get cotangent, and the complement of 90 minus theta is just theta. And likewise, the cosecant of 90 minus theta is going to be the secant of theta. Cosecant and secant are co-functions. 90 minus theta and theta are complements. And so secant of 90 minus theta is going to always be equal to the cosecant of theta, and cotangent of 90 minus theta is going to equal the tangent of theta. All right, and I think that's where we're going to stop this video. Thanks for watching.